A trigonometric identity is an equation involving trigonometric functions that is true for all values for which every expression of the equation is defined. Think of these as ways to help you do trigonometric proofs like you did geometry proofs. These are using trig information in order for you to do proofs. If you can show that a specific value of the variable of an equation makes an equation false, then you have produced a counterexample. It only takes one counterexample to prove that an equation is not an identity. So all of these are true with the exception of where you see the sine or the cosine of some function equals 0, and those are usually in situations where there is a denominator that, of course, cannot equal 0. So I'm not going to go through all these specifically, but do want to point out some of the very popular ones, particularly the quotient identities at the top. Tangent is sine divided by cosine, where cotangent is cosine divided by sine. Again, denominators cannot equal 0 in those situations. The reciprocal identities, we've already talked about in the previous lesson, how sine is the reciprocal of cosecant, and tangent and cotangents are reciprocals of each other. Some of the new ones, though, regarding the Pythagorean identities in the middle. Pythagorean identities, the first one over on the right-hand side, cosine squared theta plus sine squared theta equals 1. This is a very big identity in trigonometry. If you have some angle, take the cosine of that angle and square it, and then add to that the same angle's sine, and then square that, you will always get 1 as your answer. Same thing with tangent squared plus 1. It always equals the secant squared of theta, and cotangent squared plus 1 always equals cosecant theta. A couple of versions of the first one, the cosine squared theta plus sine squared theta equals 1, is when you solve for either cosine or sine. So let's say I solve for cosine squared theta. That means I could subtract sine squared theta from both sides. So that means that cosine squared theta equals the same as 1 minus sine squared theta. And the same for sine. Sine squared theta equals 1 minus cosine squared theta. Those are used quite a bit throughout trig proofs as well. Then you have your cofunction identities. The sine of pi over 2 or 90 degrees minus the original degree measure theta is the same as cosine. You can see those cofunction identities. And then the negative identities. The sine of a negative angle is the same as negative sine the angle. You can see those identities as well. Sometimes the negative angle identities are sometimes called odd-even identities. The identity sine, the tangent theta equals sine divided by cosine is true except for every angle measure such as 90, 270, etc., or 90 plus k times 180 where k is an integer. And basically that means it's true because it is not true because at those angle measures the cosine of theta at those angle measures would equal 0. Here's an illustration showing in which quadrant each trig function is either positive or negative. Starting in quadrant 1, all 6 trig functions are positive because in quadrant 1, both the opposite side and the adjacent side, so the opposite side being the y value and the adjacent side being the x value, as well as the hypotenuse, are all positive. So anytime you have a positive divided by a positive, you always get a positive. In the other 3 quadrants, you do have a different combination of positive and negatives. So in quadrant 2, the positive values are sine and cosecant. And the reason sine and cosecant are positive in that quadrant is because remember that sine and cosecant both involve the opposite sides, and the opposite sides would be positive, and the negative side, the adjacent side is a negative. So sine being opposite over hypotenuse and cosecant being hypotenuse over opposite would be positive over a positive, which would give you a positive. The other ones, cosine, tangent, secant, and cotangent, involve one negative value and one positive value, so those values will always be negative. In the third quadrant, the positive values are tangent and cotangent. The reason for that is that for tangent, both the opposite side and the adjacent side, so the opposite side would be a negative, and the adjacent side would also be a negative, and a negative divided by a negative is a positive. With the other four functions, you only have one negative, which means you'll have signs different that are being divided by each other, and you'll get a negative value. And in quadrant 4, the positive values are cosine and secant. So in quadrant 4, both the opposite value is negative, but the adjacent value is positive. So for cosine, you would have the positive adjacent side divided by the positive hypotenuse, which means it's a positive answer. But for, let's say, sine or even tangent, you're always going to have a positive and a negative divided by each other, which means you get a negative answer. A common mnemonic to help you remember which quadrants and which functions are positive in which quadrant would be all students take calc. All students take calc. This helps you remember which quadrants, which trig functions are positive in which quadrants. So quadrant 1, all 6 trig functions are positive in that quadrant. Students, the first letter in students is S. That means that sine is positive in quadrant 2, and its related function, its reciprocal function, cosecant, is also positive in that quadrant. Take, the first letter in the word take is T, so tangent is positive, and its reciprocal function, cotangent, is also positive. And then calc, you can see that the first letter in the word calc is C, so cosine is positive, as is its reciprocal function. So that's one common mnemonic. All students take calc. Another common mnemonic, again reading from quadrants 1 to 4, would be a smart trig class. It's kind of like what I would think that our class is. So A for all, smart for sine, T for tangent, C for class. So a smart trig class is all, S for sine, T for the tangent, and C for class. That would be cosine. Or my personal favorite, and feel free to use this with the other science teachers, all science teachers are crazy. So again, A for all, S for sine, T for tangent, are crazy, C for cosine. We can use trig identities to find the exact values of trig functions. You can find approximate values using a graphic calculator if necessary. So example 1 is find the exact value of cosine theta if sine theta is 1/4 and theta is between 90 degrees and 180 degrees. So if we want to find the cosine value and we know the sine value, a common way of doing this is use the cosine identity, the Pythagorean identity using cosine and sine. The cosine squared plus sine squared equals 1. So that's the identity I'm going to use on this one. So I'm going to use cosine squared of theta plus sine squared of theta equals 1. I'm going to use that trig identity. I know that the sine of theta equals 1/4, so I'm solving for cosine of theta. So cosine squared theta plus, I know sine of theta is 1/4, so sine squared theta means 1/4 squared. Set that equal to 1. And 1/4 squared equals 1/16. So I have cosine squared theta plus 1/16 equals 1. I'll subtract 1/16 from both sides. So that gives me cosine squared theta equals 15/16. And then in order to solve for cosine, I'm going to do a square root of both sides. So the square root of cosine squared theta is just cosine theta, which is what I'm trying to solve for. And the way you take a square root is you take the square root of the top number over the square root of the bottom number. I did square root both sides of an equation, so I use plus or minus. Square root of 15 over, and square root of 16 is just 4, and that's handy, so that means we won't have to rationalize the denominator. So I get cosine of theta equals plus or minus square root of 15 over 4. But it says find the exact value of cosine of theta if the sine of theta is 1/4, and we're dealing with between 90 and 180 degrees. So going back up to this chart, when I'm dealing with 90 to 180 degrees, I'm dealing with quadrant 2. And in quadrant 2, you can see that cosine is negative. So I'm not going to have the positive answer. I'm going to ignore that. I'm going to only have the negative answer. So the only answer is negative square root of 15 over 4. Part B, find the exact value of cosecant if cotangent theta is negative 3/5 and 270 is less than theta is less than 360. So as I go up to my trig identities, I do see that I do have right here a trig function that involves cotangent and cosecant. Cotangent squared theta plus 1 equals cosecant squared theta. So I'm going to write that down. Cotangent squared theta plus 1 equals cosecant squared theta. And cotangent of theta is negative 3/5, so that means I'm going to have negative 3/5 squared plus 1 equals cosecant squared theta. Negative 3/5 squared is 9/25. So 9/25 plus 1 equals cosecant squared theta. 9/25 plus 1 is 34/25. Cosecant squared theta. And then I will do a square root of both sides. When I do the square root of both sides, I have the square root of 34 over 5. That's what the square root of 34 over 25 is, plus or minus, of course, equals cosecant of theta. And again, we're dealing with between 270 and 360. Well, 270 to 360 is quadrant 4. And thinking about our mnemonic, which is all students take calc. Calc stands for cosine, so cosine is positive in quadrant 4. And it's related to the secant function, but this is cosecant. So cosecant is actually negative in that quadrant, so I'm not going to use the positive part, I'm going to use the negative part. So it's negative square root of 34 over 5 is the only answer. You can verify this if we go back to the top, and you can see that cosecant is right here, and it is negative in quadrant 4.